In this UV curing teaching demonstration, we seek to answer the question, what color of printer ink cures fastest under a 405 nanometer laser wavelength? Laser printing is a technology used on a daily basis that most students have been exposed to, and this demonstration uses this experience to tie in the underlying knowledge about UV curing. According to the College Board AP Chemistry Guidelines, the student should be able to evaluate the classification of a process as a physical change, chemical change, or ambiguous change based on both macroscopic observations and the distinction between rearrangement of covalent interactions and non-covalent interactions. Also, the student should be able to support the claim about whether a process is a chemical or physical change, based on whether the process involves changes in intramolecular versus intermolecular interactions. This demonstration helps to supplement these learning outcomes by providing an observable chemical change brought about by the energy of UV light. Items you'll need for this demonstration are a 405 nanometer laser, UV protective safety goggles and nitrile or latex gloves, several laser printing inks, yellow, cyan, and magenta, several pipettes, and a Q panel or other suitable surface to cure the inks to. Our setup included a ring stand and clamps to secure the laser and several paper towels upon which to place the Q panel for UV curing. Place several test spots on the Q panel with clean pipettes. Column 1, 2, and 3 correspond to different colors, while rows 1, 2, and 3 correspond to curing times of 2, 5, and 10 seconds. Once all test spots have been added, use the laser to cure each spot for the appropriate amount of time. The curing process is readily visible on the ink, and it's a good way for the students to observe the chemical reaction occurring. After curing all of the spots, wipe the uncured excess ink from the Q panel. Note that some spots are easily removed while others cure more completely. You should find that the yellow ink does not cure as quickly as the cyan or magenta ink. This is because the yellow ink does not absorb highly at the UV wavelength and is slower to react as a consequence.